Welcome to myprojectbazaar.com.
Title of our product is Frequency Boost Jitter Reduction for Voltage Controlled Ring Oscillators. Abstract of our product is the ring oscillator are popular due to their small area, modest power, wide tuning range and ease of scaling with process technology. However, their use in many applications is limited due to poor phase noise and jitter performance. Thermal noise and flicker noise contribute jitter that decreases inversely with oscillation frequency. This paper describes a frequency boost technique to reduce jitter in ring oscillators. We boost the internal oscillation frequency and introduce a frequency divider following the oscillator to maintain the desired output frequency. This approach offers reduced the jitters as well as the opportunity to trade off output jitter with power for dynamic performance management. The oscillator has 32 operating modes corresponding to different values for the ring size and frequency division. A jitter model for current steered oscillator was derived and verified by measurements. A direct relationship between oscillation frequency and jitter was derived and measured. Compared with other oscillator, this design achieves the high performance in terms of jitter per unit interval and figure of merit. The performance is expected to improve in more advanced technologies. The results are summarized to offers design guidance based on the frequency boost technique. Now we are going to discuss about the flow diagram of our product. In our product, we are using different three modules to implement the ring oscillators. They are gate current steered inverters. They are denoted as an GCSINV. Another one block is an switching block. Switching block can be contains 1:2 switching blocks and 1:7 switching blocks. And the last module is an frequency divider module. In order to obtain the removed perfect frequency in ring oscillator, we are using a frequency divider block. First, the input signal can be applied into the three gated current steered inverters, and then they are directly applied into the 1:2 switching block. In this switching block, they can be select output. They can be select the input in order to find 0 or 1s. If the input values will be 0, they are directly applied into the two gated current steered inverter. If the switch block output will be 1, they are directly applied into the another switch block. And then second, two gated current steered inverters are directly applied into the 1:2 switching block. Same process can be obtained in this switching block. They are continuously applied, and then these switching blocks can be finally applied into the frequency divider circuit. In this frequency divider, they can be implemented by using a D flip-flop. They are called as an divided by 2 D flip-flop. This is denoted as an dB. The output can be selected from the oscillator or any of the TP2 circuits. The resulting output frequency is the frequency of the oscillator divided by 2 to the power of number of DP2 stages 0 to 7. Now we are going to discuss about the running procedure of our product. In our product, we are using LT Spice 4th version tool to implement our product. First, we are going to create a new schematic using this file option. file to create a new schematic. This is our schematic. In order to assign all the components in our schematic, using this component option to select our components. Example for diode. This is a diode. In order to select some PMOS and NMOS components and start design. This is our product design. Our product design is named as a boost jitter. In order to run this process, using this save option, save to run this process. After running this run option, we are get a probe symbol for get the output signal from this design. First we select the input signal from this schematic design. This is the input of voltage VBB and VBN. Both are input for a clock pulse. Same data are applied into these both inputs in order to get the final output, using this probe option to get the final outputs. This is a final output of our product. Between these, using a frequency divider unit, we are seeing the frequency divider unit blocks. This is an output of the frequency divider. This frequency divider output can be applied into the next D flip-flop. They will produce the final output waveform. This is a final output waveform. Now we are going to full explanation of these waveforms. This is a final output waveforms for our product. VBB is an input signal. V control is a control signal of a switch. VS0 is a selection bit of the switching blocks. This is an output of the frequency divider. This frequency divider output furtherly directly applied into the D flip-flop. They will produce the final output waveform. Vout is a final output waveform of our product. Thank you for watching this video.